Okay, so in this question we're asked to find the magnitude and direction of the resultant force, okay? So we've got here these three forces going in the directions we used to. So we've got y direction here, 78 opposing at 27, and then 56 in that x direction. But then you've got one then that's been pulled on an angle, okay? So it's going to have a sort of shift in both the x and y directions. But that angle is angle alpha, and it's given to the vertical as well, okay? It's not a problem, right? But we do need to resolve 60 along here and here, okay? But what I hope you appreciate is, because you've got the angle alpha here, right? When you resolve then, okay, you'd have 60 cos alpha on this y-axis here, right? And it will be sine alpha then over here. So I'm going to write here 60 cos alpha, and here is 60 sine alpha, okay? Because you know, if you were to draw your triangle, right, there, that would be your triangle, wouldn't it? This then would be the adjacent side, wouldn't it? This would be the adjacent, so that will give you your cos value, and then this is the opposite, the angle, the opposite. So the opposite then, that will give you your sine value, okay? We do need to work out cos alpha and sine alpha, but to do that, it's not really an issue, because if you look in the question, it says tan alpha is equal to 3/4. Okay, now what that tells me is we can actually draw a right angle triangle. Okay, watch what happens now. Right angle triangle, and put alpha in there. If tan alpha is 3/4, remember tan alpha, tan is opposite over adjacent, isn't it? So the opposite of alpha there is saying is 3, and then the adjacent, okay, is going to be 4. Yeah, because that is the opposite side and that is the adjacent side. So opposite over adjacent, 3/4. And what's great about that is then you can work out your hypotenuse. You could use Pythagoras' theorem. So that squared plus that squared equals this squared, and that actually just works out to be 5. It's known as the 3, 4, 5 triangle, because you know, if you square that you get 16, square that you get 9, add them you get 25, which of course is the square of 5. Alright, so with that knowledge then we could see exactly what sine alpha and cos alpha is going to be. Sine alpha will be opposite over hypotenuse, 3/5. Cos alpha will be adjacent over hypotenuse, 4/5. Okay, so let's resolve then along the x direction. So we've got 56, take away 60 sine alpha. With sine alpha then, instead of writing sine alpha, I could put 3/5, couldn't I? Yeah, straight away. So we could say times 3/5. Okay, that's what it is, isn't it? Okay, so 56 going that way, take away then 60 times 3/5 of sine alpha. And let's work that out. And we get 20, okay, 20 newtons. Along then this direction, the y direction, so we've got 60 cos alpha, but remember cos alpha is 4/5, isn't it? Plus the 78. Take away the 27, so let's work that out. And I get 99 newtons along that y direction. Okay, so my resultant force then, we'll have 99 going that way, and 20 going this way. So there's more of a pull in the y direction, so the resultant force is going to be going like that. It's going to be quite an angle there, isn't it? Okay, and again, you know, to get the resultant, if you want to just draw a triangle to appreciate that resultant force, is saying that you're going 20 across and you're actually going up 99. Okay, that gives you resultant force, and you can see then using Pythagoras, why Pythagoras is being used. So r squared would equal 20 squared plus 99 squared, and of course you take the square over then and square root it. And you get 101 exactly. Okay, to get the angle theta, so it'd be tan theta equals opposite over adjacent, so 99 over 20, which implies then theta will be tan to the -1 of this. So theta will equal 78.6 degrees. Job done.